Once again, you're welcome to Waidsum University. This is chapter 5, part 2 of this course, the networking essential management. And now, the topic for today is the network bridge. Now, without much ado, let's begin. First of all, what is a bridge? Or what is a bridge used for? A bridge is a device that is used to connect two or more local area network. It's a device, a networking device that is used to connect two or more local area network. But however, the bridge has two fundamental functions in network. A bridge has two fundamental functions in a network. The first one is to interconnect two LAN together, two local area network together. The second one is to separate network segment. The second one is to separate network segment. Now we've mentioned network segment. What is a network segment? A segment of a network is a section of a network separated by bridges, separated by hubs, separated by switches, and separated by routers. So a segment is a section of a network that is separated by bridges, by hubs, by switches, by routers. Okay. Now the bridge is a layer 2 device in the OSI model. Meaning is in layer 2. You know, we have several layers for the OSI model. The bridge is a layer 2 device on the OSI model. That is, it uses the MAC address information to make decisions regarding forwarding data packet. So every time the bridge wants to forward the data packet, it must first of all initiate the MAC address on the port, okay, of the host on the bridge. The bridge learns the MAC address, and from there knows, okay, where this data packet is coming from and where it's going to. So the bridge uses the MAC address system by creating a MAC address table on the bridge. The bridge learns it from the computers, which computer or which host has the following MAC address of the data packet and where this data packet is supposed to be delivered to. So the bridge uses the MAC address to learn or to make decision on where to forward the data packets to every time on a network. Only the data packet needs to be sent to or across the bridge for the adjacent network. You know, remember we say a bridge can create adjacent network and segment a network A and network B. So it is only the data packet that is supposed to be sent from segment A of a network to segment B of a network that will be forwarded by a bridge. Now let's move on. A bridge is made up of two ports. For example, this particular bridge, this is a diagram explaining or showing a bridge used for creating two local area network or two segments of a local area network. Now this bridge has port 1 and port 2. Now the port 1, you can see we have LAN 1, right? We have two LANs here, LAN A and LAN B. The whole of this is LAN A. These are the computers that are connected to LAN A. Now, what you see here is that LAN A is connected to port 1 of this bridge, and LAN B is also connected to port 2. Is connected to port 2 of this bridge. So you can see, and this has created what we call the segments. You have the first this segment 1 and segment 2. So these two ports has enabled us to create two segments. Okay, has enabled us to create two segments. Now, the first segment has LAN A with 4 computers, and the second segment has LAN B with 3 computers. So this is what a bridge has enabled. And the bridge is used to create can be used to create two segments of a local area network. Is that okay? That's the point we're trying to make. Now, let's go further on the functionality of the bridge. Remember, we say they used to interconnect LANs together, and they also used to create segments. We've talked about briefly in these two functionality. We've talked about them briefly. Now let's talk about the bridges, how they use their MAC address or how they build up what we call the bridge table. Now the bridge used the MAC address to build a bridge table of MAC addresses that are available on the LAN. So they use the MAC addresses that are available on the LAN and the port location for the host connected to the bridge port. So all the particular port of those various MAC addresses are registered in a table. Okay. Now, example, we're going to illustrate this. You can see, for example, you see this MAC address of a specific computer to port 1, and this MAC address of another computer to port 1 also. What it means is that these two MAC addresses are on the same segment of this network of LAN A. And the port 2 create the second segment of LAN B. Okay, now let's move on. If you take a look at the table shows the stored MAC addresses and the port where the address are obtained from. So if you look at the first MAC address, you see it's on port 1. You look at the second MAC address, it's also on port 1. If you look at the third MAC address is on port 2, and the fourth MAC address is on port 2. Now, the source MAC address is stored into the bridge table as soon as the host talks or discusses to transmit a data packet on the LAN. So the source MAC address is stored on the bridge table. A bridge table is established because there will be association. We will talk about the association once the local area network is able to connect with the bridge and to where the destination where it's going to send the packet to, the data packet to. So an association will be established. We're going to talk about the association soonest. So we said the source MAC address is stored into the bridge table. As soon as the host talks about he wants to transmit, the host computer says, okay, you know what, the bridge, I want to transmit this data packet to another computer. So the source MAC address is immediately registered on the bridge table quickly. Maybe probably as the first one, as the first MAC address. And the port from where that MAC address is coming from is also registered on the bridge table. Okay. For example, if the computer 1 in LAN A, look at, let's say this computer 1, this one. Let's take a highlighter. Okay, let's say this computer 1 in LAN A, computer 1 in LAN A sends a message to computer 2. The bridge will store the MAC addresses of both computers, both the one that is the host where the message is coming, data packet is coming from, and the recipient that receives the computer 2 that will receive the message. So the bridge will store the MAC addresses of these two computers, okay, in their bridge table. It will build up a table. The bridge will build up a table and store the MAC addresses and the port, the particular port of both computers. Remember, they are coming from LAN A, the MAC addresses of this one and the MAC address of computer 2 with their corresponding port will be stored in a bridge table on the system, on the bridge system. Is that okay? So they will both be recorded, and both of these computers and their connected port will also be recorded. So that's what we see here. So you can see computer A, computer 1 has this. This is computer 1, the first one, this one. This is computer 1, and it has this. Is connected to port 1 also, and he's sending message to computer 2. He's sending message to computer 2, and computer 2 is also on port 1. Okay, so the bridge we designate this. We create a table called the bridge table. This bridge we register them. So the registration is the bridge table. Is that okay? Okay, let's move on quickly. Now, if on the other hand, if let's say for example computer 5 or computer 6 are placing data packets on the network, then the source MAC addresses for computer 5 and computer 6 will be stored on the bridge table as well. So if computer 5 decide to do likewise, decide to send message, let's say this computer 5 decide to send a data packet to computer 6 or to computer 7, then the bridge will register their MAC addresses quickly on his bridge table. And not only the MAC addresses, we also try to locate. It will also try to locate. You see, this is for computer 5, and this is for computer 7. Okay, this is for computer 7, the MAC address of computer 7. So their corresponding port will also be built up on the bridge table. So this is how a bridge works. Okay. So when you initiate to send, a computer initiate to send a data packet to another computer, the bridge will register both the MAC address of the sender, which is the host, and the recipient. Okay, both MAC addresses and their corresponding port will be registered on a bridge table. Is that okay? Now let's move on quickly for the sake of time. Now once this is done, the bridge will monitor the data on its port to check for an association. The bridge will monitor the data to check if there's an association. Like association is kind of like a connection. If there's a network, a connection. Now, if there's an association between the destination MAC address, if there's an association between the destination MAC address of the Ethernet frame to any of the hosts connected to the port, So the bridge will check if there's an association. Because if there's no association, the bridge cannot send what you're asking it to do for you. The bridge cannot do that. So the bridge will check for an association. If there's an association between the MAC address of the destination, the MAC address of the Ethernet frame of any of the hosts, and the MAC address of the destination. Is that okay? And if there is, then the bridge will be able to forward the data packet. So if there is an association indicates that the destination MAC address for the host is connected to one of the ports on the bridge. Association signifies that the destination MAC address where you are sending the data packets to is also connected to one of the bridge or on one of the ports on the bridge. So if it's not connected to one of either of these ports, then there will be no association, and the bridge will not be able to forward it to the computer because it's not available. Is that okay? Now let's move on quickly. Now, if an association is found, the data is forwarded to the port. If association is found, let's say the association is on the other side or the segment of the LAN, the other LAN or the other side, then once an association is found, the data packet is forwarded to the port. Okay? The data packet is forwarded to the port, and there also the particular computer that the message is sent to, the recipient. Now, the recipient will receive the message. So we say if an association is found, the data is forwarded to the port, right? For example, let's take an example. You say, assume that computer 1, let's assume that this computer 1, sends a message to computer 5, wants to send a message to computer 5. Remember that this computer 5 is not on the same LAN. The LAN, computer 1 is on LAN A, local area network A, and computer 5 is on local area network B. So let's assume that a computer 1 wants to send a message to computer 5. The bridge detects an association. Because why? Because both LAN, local area networks, are connected to either port of the bridge. So the bridge will be able to detect an association between the destination MAC address for computer 5 and the host MAC address for computer 2, of port 2, and the host MAC address, host MAC address of computer 1 on port 1. Okay? So the bridge then forwards the data packet from computer 1 to computer 5 in LAN B via port 2. It will forward it via port 2. Remember, this is port 2. Port 2 is here. Let's move this one here. Remember, the port 2 is here. The bridge will be able to forward it to this place. Is that okay? The bridge will be able to forward it to this place. Let's move it back. Okay, now let's move ahead. That's how it works. Okay? Now, association. Association is the capability or the ability of a bridge to only forward data packet when there is an association, when there is a connection between ports or between computers in different LANs within the various ports on the bridge. So it is the capability of the bridge to only forward the data packets when there is an association, and is used to isolate data traffic in each segment. When there's traffic, it will be used to isolate the data traffic whenever it arises. Now let's go to some problems that we always encounter with the bridge. One of the big problems we encounter with using bridges for local area network is broadcast. Now, how is this a broadcast? How is this a problem? How is a broadcast a problem? Remember, one of the big potential problem with bridges has to do with the way broadcasts are handled. Now, all broadcasts in a local area network will be forwarded to all the hosts connected with the bridge network. This is the challenge. All the broadcasts in a local area network will be forwarded to all the hosts connected to or within the bridge network. Instead of like filtering and selecting which particular one that is this data packet is supposed to be sent to, then it will not do that. It will send all of it to all the hosts, all the computers on the host in the bridge. So this is one big problem. This is one big challenge that we have with using a bridge in a network, in a local area network. For example, the broadcast associated with an what you call ARP, and ARP is Address Resolution Protocol. Okay, Address Resolution Protocol. The brokers associated with an ARP will appear on all the hosts. So the broker's address you send through an address resolution protocol will appear on all the hosts. In the address resolution protocol, a broker is sent to all hosts and in a LAN connected to the bridge. Now let's explain this concept. What do we mean by this concept? First of all, what is an ARP? What is an ARP? Okay? What is an ARP? An ARP is an address resolution protocol. It's an address resolution protocol, which is a procedure for mapping dynamic IP addresses to a physical computer or to a physical machine. An ARP is a procedure that is used for mapping dynamic IP addresses to a physical machine. Physical machine could be your media access control, which is your MAC address, okay, in a local area network. So an ARP, what we call the address resolution protocol, is a procedure that is used for mapping the dynamic IP addresses to your MAC address, mapping the IP addresses to all the physical machines, which are your computers. Your computers every computer has its own MAC address, media access control. So the protocols that is used, or the procedure that is used for mapping dynamically the IP addresses of a network to your MAC address of your computer in your local area network is called the ARP, which is the address resolution protocol. Is that okay? Now, the ARP always requests broadcasting the message. For example, if ARP requests a broadcasting, like a message, a specific message, like who has this IP address? Let's say this is a specific message that is requested by ARP, Address Resolution Protocol. When he requests for this broadcast, he say, oh, who has this IP address? This who has this IP address will be sent to all the hosts on the LAN. Okay? Okay, so this is one. This is what an ARP is used for. This is what an ARP is used for. An ARP is used to carry out a procedure. It's a procedure that is used to carry out the mapping of an IP address or to a MAC address. Okay, because in itself it's an address resolution protocol. It's an address resolution protocol. Now let's move on quickly for the sake of time. Now, the bridge forwards all brokers. This, remember we said this is one of the challenges we have in using bridges. The bridge always forward all brokers on a network to all the hosts. Now, therefore, an ARP requests broadcasting the message who has this IP address, and this message who has this IP address is sent to all the hosts on the LAN. The data packet associated with ARP requests are small. Even when they are small, even when the data packets associated with the ARP requests are small, but it requires computer time to process each ARP request. Why is this so? Why does it require computer time to process this? Because everything is broadcasted to all the hosts on the network, right? So it will definitely require, there's traffic already, to require time for this to be processed, right? Now, excessive amount of broadcasting being forwarded by the bridge can lead to what we call the broadcast storm. Now, this is a negative or a bad side of using a bridge in a network, because it's always doing what we call excessive broadcasting everything to all the hosts on the network, This can result to a negative or adverse effect called the broadcast storm. Okay, and this can degrade the network performance. This can reduce the utility of the network and the performance of the network, right? Okay, so this will affect the performance of the network, and this will eventually slow your network down. So this is the disadvantage of using a bridge. Other than this, a bridge is very fantastic. To use. Now let's move on. Bridge table expiration counter. Now, A bridge table, all the, we say the bridge table learn all the MAC addresses from the host and the destination. But this does not last forever. They last for a specific time and they expire. After that, they wiped off. The MAC address entry is stored in a bridge table, right? But this storage is only temporary. It's not permanent. Now, each MAC address entry into the bridge table remain active as long as there is a periodic data traffic activity from the host on the port. As long as, for a period of time, as long as the host is still busy, there's still data traffic with the host on the port. As the moment the host is no longer busy, then the MAC address will be lost. So the storage is not permanent; it's only temporary. The storage on the bridge table of MAC addresses on the bridge table is only temporary. It's not permanent. However, you have nothing to worry about. Anytime the port becomes back live, become busy, then it will learn about the MAC address of this host computers or the destination computers again. So you have nothing to worry about. Even if it's not active, there's no data traffic. The MAC address are lost from the bridge table. They expired. We say they've expired. So they will be deleted from the bridge table. However, whenever the port connected to the segment of the LAN is back, is live again, is busy, it has a data traffic, then the bridge table learns the MAC addresses of the host computers and the destination computers. Is that okay? So we say an entry to the table is deleted if the port becomes inactive. I think I've explained this concept. It is deleted the moment the port is inactive. All the entries into the table will be deleted. Okay, I also say don't worry. Whenever the port becomes active again, the port will learn the port of the bridge will learn the MAC addresses of the host and the destination. Okay, and enter them into the bridge table once again. Now the entries stored in the table will have a limited lifespan. No longer, it's not going to be there forever. They only have limited lifespan and they have expiration date. An expiration timer will commence once the MAC address is entered into the bridge table. The moment you enter the MAC address to the bridge table, expiration timer will start. It's just like the moment God gives you life, okay, your expiration starts. It starts counting. The moment you are given life, your death is coming. Start counting. The time you go to die, start counting. That's the same thing that is happening here. Okay, the moment the timer commences, the expiration timer will commence once the MAC address is entered into the bridge table. It will just start. Okay, then once the port becomes inactive, then it will be deleted. The lifetime for the entry is renewed by new data traffic. Every time there's a data traffic, then it will be restored. Okay, I've mentioned this. Now let's move on to save time. Now, what you see here is what we call the ARP cache. What you see here is called the ARP cache. Okay, all networking devices, all your computers that you use for networking device, whether they are laptop or desktop, whatever it is that you use for your networking devices, they contain what we call the ARP cache. You remember I say ARP is the address resolution protocol. So they have what we call the ARP cache. Now, the ARP cache is a temporary storage of the MAC addresses that is recently contacted by the port. All the MAC addresses that is recently contacted by the port or the bridge is stored temporarily in the cache, in this ARP. This is also called the ARP table. So apart from having what we call the bridge table, we have what we call the ARP table, the address resolution table. The address resolution table cache holds the MAC addresses of the host, and this enables the message to be sent directly to the destination MAC address without the computer having issues with the ARP request and the MAC address. So whatever is stored here enables it to be sent to the destination without having problem with the MAC address. Okay, the MAC address is temporarily stored on the ARP table. So anytime the data packet is to be sent, it learns it from the ARP table quickly and send it to the destination address. Is that okay? Now the ARP cache content on the window contains of the computer, or what you see here is a window of the computers. What you see here, what you view here is an ARP using a command A. So once you type command, what you call the command A, ARP dash command A on the window, you have this. If association is established, if an association is established and you type in your C, you type ARP-A command, then you will see this will be displayed. This will be displayed on your window. Is that okay? But if there is no association, this is what you're going to see. If you type the command ARP-A command, if there's no association, you see no ARP entries found. This message is generated if all the ARP entries have expired or if you don't find them. Okay? Now let's move on for the sake of time. There's what we call the transparent bridge. The name transparent bridge is used. Okay? We say a bridge is transparent if it has the same type of protocol. If the segments, a bridge have two segments, two LANs, two local area network created by port 1. Port 1 has its own local area network. Port 2 has its own local area network. So if they are running the same type of protocol, the same Ethernet, then we say this bridge, this is a transparent bridge. A bridge can be used by using the same protocol and can be used for different protocols, right? We mentioned this. If it's used for same protocol, if bridge is running on the same protocol for both port 1 or both local area network A and local area network B are running on the same protocol, then we say this bridge is called a transparent bridge. A transparent bridge is a bridge that runs on the same protocols, okay? It's a bridge that runs on the same protocol on the network, okay? Now, bridges are also used to interconnect two local area networks that are operating on two different networking protocols. You can also use bridge to connect operations that are running on two different protocols. So not only same protocol that a bridge can be used to connect in a network, a bridge can be used to connect operations or two LANs that are running on different protocols. For example, if LAN A could be an Ethernet LAN, LAN B could be a token ring LAN. So the token ring LAN and Ethernet LAN, they are two different protocols that are being used by this local area network. So a bridge can be used to do these two connections together. Now, here is a table. This table is summarizing the advantages of using a bridge in interconnecting local area network. The advantage of using bridges in interconnecting local area network. Number one is it is easy to install. Bridges are very easy to install. Number two is that it does an excellent job for isolating data traffic in the two segments. The bridge does excellent job in isolating the data traffic in the two segments. That's advantage number two, or merit number two. Merit number three is that bridges are relatively inexpensive, meaning they are not expensive. They are relatively inexpensive. Advantage number three is that bridges can be used to interconnect two LANs with different protocols. You see, not only two LANs that are running on the same protocols. Bridges can be used to interconnect two LANs running on different protocols or different hardwares. Okay, this is the third or fourth advantage of using a bridge. The fifth advantage is that bridges can be used to reduce collision domain. Can be used to reduce collision domains. Remember how the CSMA and CD protocol works. We've described this before. So bridges are used to reduce collision domain. So if the domain is busy, if there's a traffic, then it will kind of notify the other one not to send any data packet because it's busy. When it's free, then this technology, this CSMA /CD, this is how this technology is used. So bridging is in adherence with the CSMA technology. That's why it's able to reduce what we call the collision domain. Then let's take a look at the disadvantage of using a bridge to interconnect our local area network. One of the disadvantages of using a bridge in interconnecting our local area network is that it works best in low traffic area. So if you're using a very high traffic density area, bridges are not the best suitable. Okay, wherever you have high traffic area, density area, bridges are not super best devices that you should use for interconnecting your local area network. Then another disadvantage is that bridges forward broadcast, and it's susceptible to broadcast storm. Bridges in a short form, you can say bridges can cause what we call broadcast storm. Remember, broadcast storm can cause network delay, slowness in the network, and all other bottleneck that may not give us the super advantages or super optimal performance of a network. So bridges causes what we call the network storm, which we've explained before. Okay, so these are the advantages and disadvantages of using a bridge. Now let's talk a little bit about bridges of today's bridges. A common application today in using bridges is interconnecting local area network using wireless technology. Bridges today, they use what we call the wireless technology. Okay, they use the wireless technology to interconnect our local area network. Now the use of wireless bridges now we have wireless bridges that you don't have to use the twisted pair cable or optical fiber cables to connect. We have wireless bridges like the one we use in our homes now or in our offices now, like the one that give us our specific Wi-Fi by Telecom Malaysia. Okay, these ones are wireless bridges and wireless switches and wireless routers. This is what we're using now. Is that okay? Now we say the use of wireless bridges in local area network is now popular choice for interconnecting the LANs when the cost of physically connecting the LAN is prohibitable. Okay, it's prohibitive, like it's too high, it's like prohibited. You cannot afford the cost. So when it's too high, then wireless bridges becomes a super option for us, right? So with this, we've come to the end of this section. And remember, we've talked about bridges, we've talked about the bridge table, we've explained association, we've explained the broadcast term, we've explained network slowdown, we've explained the ARP cache, that's the address resolution protocol cache. We've explained ARP table. We have explained what we mean by the transparent bridge. Is that okay? Transparent bridge is a bridge that operates with the same protocol. Two LANs that connect two LANs with same protocols. Okay, operating on the same protocol. Okay, so this is what we have for today. Thank you for joining our class. Okay.